Hey yo, hey yo, hey yo. So we're back with section C slash part C of part 3 of grade 5 of the Show Your Work hardest math problems. I'm Greg from GregsTutoringNYC.com. Oh yeah. All right, so we're going to just jump into this here. We have what looks like garbage cans or something. We have A. We have 2/3. So this curly brace thing here seems to be applying to these words here. This here seems to be applying to that. So it tells us that it's implying that B is 2/3 of the amount of A, and that C is 2/3 of the amount of B. There doesn't really seem to be much more we can get out of the illustration, so let's jump into the words. The diagram below shows a set of 3 different containers, A, B, and C, that Tana used for storing dry goods. The largest container had 12 3/4 cups, okay, of dry goods over here. What was the total amount of the dry goods in all 3? So we're looking for the total being the total that A has plus the total that B has plus the total that container C has. Okay, so we know what A is, and we have to figure out what B is. So of means normally multiplication. So it's 2/3 of. So what we really need to get is 12 3/4 times 2/3. Okay, to me, the easiest way to do that is to probably convert this into a top-heavy fraction. So 12 3/4, you got 48, we get 50 1/4 times 2/3. Okay, I can cancel that 2 into that 4, and that will give me 50 1/6, I believe. Actually, we can do that one other step because the 3 wanted to here 17 times. All right, so we could have gotten, what could we get there? 17 halves, is that? We can do that here. We can drive the 3 into here. 3 goes into 6 twice. 3 goes into the 51 17 times. Most students don't know that this is not a prime number. 5 plus 1 is 6, so therefore it's divisible by 3, since the sum of its digits is divisible by 3. This is a gotcha on a lot of exams that you guys end up getting that. So that implies that this is 12 3/4, or as we did 50 1/4. Okay, B is 17 halves. Okay, and C is 2/3 of B. So it seems we need to get that 17 halves again. Again, of means multiplication, and multiply that by 2/3. These 2's cancel, okay, and that's equal to 17/3. All right, by the way, just to take a sidebar conversation, we're going to go with the left over here for a second. Enough of you know that if I have A times B over C times D, I can split this in different ways. Okay, so if I have, for instance, 5 times 2 over 4 times 8, most of you realize you can cancel this 2 into either the 4 or the 8. But when it's split across like this, most of you don't realize you can still do that. So the 2 can go into the 8 or into the 4, because we can move between the 2 of these as much as we want, right? We can map these 2 are identities. They're the same operation being requested of it. We just split it into 2 fractions versus a numerator with a multiplication and the denominator with multiplication. So that's how I can cancel across the fractions, because I was going to get, if I didn't do that, right, I was going to get 17 times 2 over 2 times 3. You know, if we actually, that's a bad 3. If we actually did that, we would get 34 over 6. And we can still divide the both of those by 2 to get 17 over 3, which is what I had in the first place. So if we fill in C now our job is to actually get common denominators. So the common denominator here is 12ths. Okay, so this is slightly nasty. We're going to have to do various combinations of stuff. In any event, 4 times 3 is 12, so 51 times 3 is 153. Okay, this is 6, so we need to get 17 times 6. That's 2, 4, 6, that's 102, 102 twelfths. And this is 4, so we get 1734, we get 68 twelfths. Okay, so now we need to add those up. We're going to have 153 plus 102 plus 68. Before I do that, I just want to double check that I did that right. That was 17 halves, that's 17 thirds, 51 fourths times 3, 153, cool. Times 6, 60 plus 42 is 102, yes. Then what I did for here is I just denominated into 4, so 17 times 2 is 34, and times 2 is 68, cool. So now let's do the addition. 8 plus 2 is 10, plus that is 3. Carry 1, I got 6 plus 6 is 12, 2. Carry 1, I get 323 twelfths. Okay, so now we actually have to do that division. Okay, 12 goes into 3, it doesn't. 12 goes into 2. Well, 3 times is 36, so it must be 2. So I get 24. I have 8 left over, so you need to know your 12 times table. 6 times 12 is 72. 6 times 8 is 96. So that would be 6. We get 72, right? 83 minus 72 is 11. So we get 26 and 11 twelfths. Okay, and that turns out to be our answer. Okay, there's a couple ways, other ways we could have done this, involving different ways to do the fractions. You guys can explore that on your own. What I do want to leave you with, and by the way, you could have used decimals to do this too, but that gets super ugly. You know, because, let me change the color of the pen here just to talk about that. So if this was 12.75, the problem is 2/3 is 6,666,666,666. So it's 0.6 bar. And to do that multiplication gets whacked out. So this is an example where using decimals is not really appropriate. Okay, but what I am going to do is shift this up slightly, and we can consider this algebraically, because we know that A is 12 3/4. Or if it helps us, we already know also that it was 51 fourths. We don't know where we're going with this. So B is 2/3 A. Okay, and C is 2/3 of B, right? And our total was still this here. So if we redo that the total is A plus B plus C, okay, and we start substituting stuff in, right? That means this is A plus B was 2/3 of A, and C was 2/3 of B. So after that substitution, we're still left with the B. So we can replace it one more time. So that's equal to A plus 2/3 of A plus 2/3 of 2/3 of A. See what happened there? And this also maps into something else. Because if we spin out the A, now every term, this has an A in it, this has an A in it, that has an A in it. So that's equal to A times 1 plus 2/3 plus 2/3 times 2/3. Okay? And that's equal to A times 1 plus 2/3 plus 4/9. Okay? And then that's equal to 1, A times 1, plus, and if we have 9ths and thirds, we're trying to end up getting a common denominator out of that. Okay? So we have 9ths, so 18ths seems to work as our least common denominator. So if you notice, I just put it in there and then fill it in. 2/3, 3 times 6 is 18, so 2 times 6 is 12. And for the 9ths is times 2, so this is 8. Okay, and if we continue that down, that's equal to A times 1 plus 20/18. And I hope I've done all this correctly. And that's the same as 1 plus 1 and 2/18, right? So that's equal to A times 2 and 2/18, which is the same as A times 2 and 1/9, or 2 and 1/9 times A. Okay, now if that whole thing, that we're talking about the total now, right? So if the total equals 2 and 1/9 A, and A was the 12 3/4, that's what we have. We have 2 and 1/9 times the 12 3/4. Okay, so we can either do this as fractions, or go top heavy. So 2 and 1/9 is 18, that's 19/9 times, and we know this was the 51/4. Okay, so now what we have to do is bring it into that. The bottom is going to be 36. The top is going to be 19 times 51. So we get 19, we get 5, 4, we get 9, we get 969. Let me just make sure that's the correct thing. So we have 51 times 19. I'm going to do it opposite. So we get 9. 9 times 5 is 45. And then I get 51. So we get 969. Right, 969 over 36. Okay, so we actually do that division now. Okay, once seems cool. 3 times, it's going to be over because 30 times 3 is 90. So we're going to get 2 here. We get 72. Okay, we get 22 there. No, 20. Okay, I added these, so this should be a 4. So we're shooting for 249. We already showed that the 7 was too large. So it's going to be 6, right? We know that's 216 because I did that above. Okay, so we got 3. So we get 33, 36, which is the same as 26. and 11/12, which was what we got earlier. Right? Come over here. All right, so that was a doozy of a problem. That's an algebraic way. This is beyond grade 5, but still kind of cool to consider. So the concepts here was fractions of, not only fractions, but fractions of, because the 2/3 of was one of the things there. It was your fluidity and fractions. You're using a lot of multiplication, a lot of operations to addition to. It was really to understand what the capacity was about. And if you go to the end here, it just says cups. The answer's in cups. Okay, so we need to kind of be concerned about that as well. All right, and then finally, so there's a lot of fractions flying all over the place here. Finally, we're going to do the last question, which I believe is the last question. So a juice company produced 8,064 cartons of juice in 21 days. Okay, so that's kind of our first thing there. They're really going to test ourselves here. Each day they produce the same number of cartons in 16 coffee shops. They were delivered in 6 cartons per case. Each received an equal number. Look, we're going back to that same thing. How many cases were delivered? All right, so this is just a grandiose division problem. If there was 8,064 cartons, then each day we need to do that, right? So we can divide that into there. 4 is too many, so that's going to be 3. Okay, that'll give us 63, which what gives us 17 still. 60, 70, 80, yep, 176. So that might give us 8. Yep, we have 168. So that'll give us 8 left over there. That'll give us 84, and that 21 goes into 84 4 times. So there's 324 cartons per day. Each day there's 384 cartons per day. And we can double check that. 384 times 21. These checks are important, because otherwise you're going to spend a lot of time going through the other questions not doing what, using the wrong initial numbers. 4 times 2 is 8. 8 times 2 is 16. 1, 3, 6, 7. Okay, we get 4, 8, 6, 1, 6, 7, 8, 9, 10, 0. So we get the 8064 back. Cool. All right. So we're up to here right now. Each day they produce the same number of cartons and delivered to 16 coffee shops. So now we need to figure out the number of cartons each coffee shop got per day. Okay, so 6 times 2 is 32. We're going to have 6 left over, and that's 4. We can double check that. 16 times 24. 6 times 4 is 24. Count my 2, 4, 6. I get 6 times 2 is 12. 1, 3. And I got 384. Cool, that checks out. So this is 24 cartons per coffee shop per day. All right. So then we're up to here. So the cartons were delivered in cases of 6. So how many cases? How many cases? And that turns out to be the question. So what we have is 6 going into 24 and getting us 4. All right? So this is kind of 4 or 5 steps here. Not terribly hard math. It's basic arithmetic at the levels of the division and the multiplication. But it still is a word problem. It's still knowing your multiplication table. it's still trying to rip this apart. There's more elaborate ways to have done this. I'm not even sure I kind of show it, but let me change the color just to be clear of that. So what we're really doing is 8064, right, divided by 21. And that whole thing divided by 16. And that whole thing divided by 6. All right, so that starts getting nasty when we look at that. But if we take this by itself, this means 8064 divided by 21. If we now take this part here, this means it's that divided by 16. So we can multiply that, because this is the same as 16 over 1. So we're going to get 8064 over 21 times 1 over 16, right? Because division by a fraction is the same as multiplication by its reciprocal. And now we're taking that whole thing and dividing that by 6. So for the same reason, this is 8024 over 21 times 1 over 16. Well, this is the same as that, so this is times 1 over 6. Okay? That was a 16. So that gives us 8024 over this 21 times 16 times 6. All right? So we can actually do that. 21 times 16. We get 6, 12, 21. So that should be 236. And I'll do it backwards just to be sure. 16 times 21. That's going to give me 16. 2 times that is 2, 1, 3. Okay, so I got 6, 3, 3. So they each give me 336. That's doing this so far. So now I have to multiply that by the 6. 6 times 6 is 36. 6, carry on my 3. 6 times 3 is 18. 19, 20, 21. Carry on my 2. 6 times 3 is 18. 19, 20. All right? So we are going to get the 8024 over 2016. Now, for this to be 4, we know the answer is 4 already. This should have been 8021. So I goofed up somewhere. So let me double check all this. 8064 divided by 21. 21 times 16, 6. Even though I double checked it. 6, 12, 1, 2, 3, 3, 6. 336 looks correct. Let me try that calculation again. 336 times 6. 6 times 6 is 36. Carry on my 3. 18, 19, 21. 1. Carry on my 2. 6 times 3 is 18. I get 2016. That is not right. Okay, here's my error. This is not 8024. I made an error in carrying this, so this is 8064. 8064. Okay, so now 8064 divided by 2016 is definitely a 4. All right, so we're able to get the right answer. Whew. All right, okay. Let me just double check that I did all the questions here. That's 46, 47, 48, 49, 50, 51, 52, 53, 54, and 55. And if you notice, I made a mistake on that last one there. What's important to do is to be able to catch an error and see why something is happening or not. All right? Not panic, not flip out. Just take it a piece at a time. First of all, we already had the answer, and I was actually doing a more involved way. I often like to avoid these kinds of ugly calculations. In fact, even if I didn't know the answer, these kind of tests normally are easier. So if I had 8064 over the 21 times the 16 times the 6, I already know this is divisible by 3 and 7 for that matter. So I would actually test to see if the numerator is divisible by 7. So it's 1, let me do 8064. Divisible by 7. That's 1 with 1 left over. That's 1 with 3 left over. That's 5 with 1 left over. Yeah, it would go into there. So let's just double check that. 1152 times 7. 7 times 2 is 14. 1, 35, 36. All right. And then 7, 7. Wait, what did I just do then? 7 goes into 8 once, with 1 left over. 7 goes into 10 once with 3 left over. 7 goes into 36 5 times with 1 left over. So 1152 times 7 sometimes is 14, 1, 35, 36, 3. That should have been 3. All right. Yeah, so we get the 8064 back. Okay. So that meant this would have been 3, and this would end up being the 1152. Okay. Now I have 3 at the bottom. Is 1152 divisible by 3? Well, if I add the sum of its digits, I get 9. So it is. So I can get 3 into 3 once, and 3 goes into 1152. That's 3, that's 9, that's 2, that's 8, 1, 4. We get 384 over that. At this point, we could try the 6. The 6 seems likely. 6 goes into here 6 times. With 2 left over, that's 64. So we basically have 64 over 16. Okay, that's equal to 4. Okay, in this scenario, these numbers were still too ugly to work with, but it's still cool that we were able to get the same answer. All right, with that in mind, I hope you're all good. Please like and subscribe, and we're going to come back with the part 4. Yeah.